Today I will be showing you how to do a stoichiometry problem, but first I will give you some background on the problem I will be doing. The problem I'm doing has to do with the Ostwald process. This process was patented in 1902 by William Ostwald. It is the process by which nitric acid is made. This acid is crucial to the fertilizer and explosive industries, and this is William Ostwald. How much nitric acid would be produced if you start with 5 kilograms of ammonium? And your problem is 3 steps because you start with ammonium and you get nitric acid. First you need to convert kilograms to grams because in stoichiometry you use grams. So there is 1,000 grams in 1 kilogram, so you have 5 times 10 to the third grams. You know you have 5, this is your 5 kilograms, so you have 5 times 10 to the 3 grams, and that's what you start with down here. And you make your units cancel. So you have 5 times 10 to the third grams of ammonium, and then you'll go to moles of ammonium, and then from moles of ammonium to moles of nitric monoxide, and then to grams of nitric monoxide. And your 17 comes from your break it down thing because nitric is 14, has a molar mass of 14, and hydrogen has a molar mass of 1, and there's 3 of them. So you do it times 3 and you get 17. So you do 5 times 10 to the third times 30 because your 4 to 4 will cancel out because that'll equal 1, so it really will not matter. And then you divide by 17 and you get 8,820 grams of nitrogen monoxide. But then you have to do times 94% because this is theoretical, not 100%. It's not perfect in perfect conditions, it's just in normal conditions. So then you get 8,290 grams of nitrogen monoxide. Then you take that number and you need to figure out how many grams of nitrogen dioxide. And then you cancel your units out again. And then you do 8,290 times, this will be 1 again, so it'll be times 46, which is your break it down thing I showed you in the previous problem. And your 30 for nitrogen monoxide, and then your 46 for nitrogen dioxide. And then 8,290 times 46 divided by 30 is 12,700, and you times its time your 94% again because it's theoretical, and you get 11,900 grams of nitrogen dioxide. Then you take that, and this is where you find out how many grams of nitric acid you will get. You cancel your units out again, and then you get 11,900 times 2 times 63 divided by 46 divided by 3, and you get 10,900. And then you multiply it times your 94% again, and you get 10,200 grams of nitric acid. Then you write your answer in scientific notation because this is stoichiometry, and you move 4 place values to the left so your exponent goes up. So you have 1.02 times 10 to the 4 grams of nitrogen monoxide. And then you started with kilograms, so you want to go back to grams. You started with kilograms, so you want to go from grams back to kilograms. So you do 1.02 times 10 to the 4, and then you divide it by 10 to the 3, which in reality you just subtract the exponents because this is on the bottom. So you have 1.02 times 10 to the 1 kilograms of ammonium. And that's how you do stoichiometry.